All right. So in today's video, I would like to share to you guys how to do the correlational analysis using Python. All right. So I have data what you see from the screen here using Excel formats. So I have rewards and competence. I have two variables, which is rewards as independent variables, and competence, nurse competency is dependent variable. I'd like to know whether there is a correlation between rewards and competence, right? So here we can see from the screen that I'm using Spider Python 3.11. So I'm using this one because it's quite interactive. So I can see the console here, and it's quite similar with the R if you get familiar with R. Alright, so first thing first, you can see from the screen here, I'm gonna import all the library here. There's pandas. Okay, it's like for reading the data, data cleaning and transformations, and I use SciPy stats and Matplotlib, and Seaborns is for data visualizations and stats model for statistical analysis, and also here, Bridgepagan is for checking heteroscedasticity. So I'm gonna import this one first. So you can see from the screen, the console, all right, it's imported. And I'm gonna load my Excel file here. I'm gonna load the Excel files. Well, it's already read, and I'm trying to display it. Okay, well, you can see from the screen that I have 230 samples, right? Rewards and competence. And I'm gonna check whether there are missing variables here. This is we call check finance in the data. Alright, so I'm gonna run this one, and there is no missing variable 0 and 0, right? And next, I'm gonna extract variables. Okay, and I'm gonna check for the normality, right? Here, the first one we are using Sapiro will taste. Okay, it's executed, and then we check print this out. So we can see here statistic 0.9 and value 0.056, and for the competence is 0.98 and v value 0.07. And as a proper interpretation here, what you can do, you can just print this out, and here's the result for the interpretations. Rewards data is normally distributed, and competence data is normally distributed as well. All right. And usually when we are using SPSS, for the samples that's more than 200 or more than 100, we can use Kolmogorov-Smirnov. And I also provide you here how to perform Kolmogorov-Smirnov here. And we can do this, right? And then run this out, and then we can print. Right, so it's the result of Kolmogorov-Smirnov. You can see for the interpretation here. Right, so data is normally distributed and data is normally distributed for competence. Okay, so it means the data is normally distributed, but not until there. We're trying to do, check the normality using histogram and Kiki plot as well. So, all right, so here for the Kiki plot, it looks like normal to me, and you can see also from histogram, I think both of them looks normal to me. And you can see, you can do the interpretation here as well. All right, what they say, bell-shaped histogram and points closely following the diagonal line. Kiki plot suggests normality. Okay, this is for the supporting normality. But for the skewness and departure from the diagonal line may indicate deviation from normality. Yeah, just a little bit, but it can be normal, right? And let's say for the scatter plot here, can run this out. You can see here, and you can see the interpretations. Right. Scatter plot indicates the relationship between two variables, okay, rewards and competence. Offsetting patterns, linear suggests potential relationship between the variables, which is also good. And here for the Pearson correlation, because data is normally distributed, we do the Pearson correlations. And here's the results. Correlation coefficient 0.98 and p-value is less than 0.05. But before that, we also need to test for the heteroscedasticity, whether it's violated or not. We run this ad. Okay, here are the results, and we can check for the interpretation here. Homoscedasticity is the assumption not violated, so it is also good. So we can see for the interpretation here, if we are using Pearson's, so Pearson correlation is significant, which is with R 0.989 and the value 0.0. Okay, and then if your data are not normally distributed, you can use Spearman ring correlation here, which is I provided as well here, and for the interpretations. Well, that's it. That's an easy way to do. Right?